In this video, we're going to look at how to find out your displacement values along your beams. So come over here into Rhino. So what we're going to do here, we have already set up our load condition, we've selected our beam, or we can variably select our beams. We have the assemble component, the model view, and analyze. And then out of analyze, we can do two different things. The directly below the model output is a displacement output, and we can plug that into a panel and find out what our maximum displacement is for the entirety of the model, which is useful information, but we might want more specific to find out what the displacement is along a specific beam. And to do that, we want the beam displacement component, and to get that one we double click. We can start to type beam, and then select the beam displacement component, and off of that we can pull a panel and we can find out what the displacements are on any given beam. And the way to know what beam we're looking at is over here in the model view to come down to element tags. So if we turn on element tags, then each one of our beam components, it's sort of hard to see here, but each one of those is labeled with a number. Let's go ahead and actually turn off those loads so we can see that better. So here in the display scales, you can click on this load box and turn those off. So you'll see here each one of these beams is labeled with a number, and that number corresponds, it's actually the tree branch in Grasshopper. And you'll notice I have a simplify display on here, and that's just to make this read as one number. This is still 0, 1, 2, 3, but I think it's easier to see when it's simplified. So each one of these sections refers to one of these beams, and the other thing we need to do is actually make this so this is displaying 3 points for each beam. Inherently, if we don't have a panel attached here, you get 2 points, and what this is telling you is the displacement at the end point for each one of those beam components, which, you know, is useful information, but the maximum displacement tends to be in the middle of a beam. So to do that, we want to change this number of results per element to 3. So we double click and just make a panel with the number 3. And what that'll do is add a center point onto each beam. So if we connect that, now our middle value for each one of these beams is the maximum displacement. And so what we can do is, if we want to just find out for the total condition, which one is the maximum, we can look at the maximum displacement for the model, and then we can find that number over here. And if I turn my loads back on, just because of the way I have these beams spaced, there's an uneven loading condition, and beam number 1 gets a lot more load than anyone else, so I would expect that beam number 1 would have the maximum displacement, and in fact it does. So the next thing we want to do is see if our maximum displacement fits in our constraint of length over 360. So my length for these shorter members is about 25 feet. So if I take 25 and I divide by 360, I get 0.69. And I had preset this, which is why it's correct, but this member fits within that displacement. So using a W14 by 82, I meet the requirements.